Hey guys, here we are for lesson 8, comparing equations with relationships with equations. We are on page 63. So, notice and wonder, do you see a pattern? What predictions can you make about future rectangles in the set if your pattern continues? Well, I'll go ahead and hit pause. Think about what you notice, what you wonder about things. Can we predict what the rectangle is going to look like? So go ahead and hit pause, think about it, and then hit play again. All right, hopefully you've had time to think about it. Now, if you notice here, get my pen working, we increase by 3 squares this way every time, and we increase by 1 square this way every time. Okay, so can we predict what the next one's going to look like? Yeah. Right now, this one is 3 squares by 9 squares. Well, if we add 3 more squares, the next one's going to be 12 squares wide and 4 squares. And the next one's going to be 5 and 15 and 6 and 18, and we can just keep on going. Okay? So, moving on, if we turn the page to 64, more conversions. The other day you worked with converting meters, centimeters, and millimeters. Today, here are some more unit conversions. Number 1, use the equation F equals 9/5 C plus 32, where F represents the degrees in Fahrenheit and C represents the degrees in Celsius to complete the table. So this is the conversion that we use when we're trying to convert from Celsius to Fahrenheit. So, all I'm going to do is I'm going to use my calculator, I'm going to use the ABC button. I'm going to take these numbers, 24 and 175, and I'm going to plug them in right here for C. Okay, so first thing I'm going to do is I'm going to go 9 ABC 5, 9/5 times 20 plus 32. And I get 68 degrees. So my temperature over here is 68. Then I'm going to go 9 ABC 5, 9/5 times 4 plus 32 gives me 39.2 degrees. And then I'm going to go 9 ABC 5, 9/5 times 175 plus 32. I get 347 degrees. Okay? Now, number 2, use the equation C equals 2.54n, where C represents the length in centimeters and n represents the length in inches. So I'm going to take all of these inches, 10, 8, and 3.5, and I'm going to plug them in right here for n. So I'm just going to multiply all of them by 2.54. So 2.54 times 10 is 25.4. 8 times 2.54 is 20.32. And 3.5 times 2.54 is 8.89. Are these proportional relationships? Explain why or why not. So, if we go back and we look here, if we go second column divided by first column, if all the numbers are the same, which we learned in lesson 7, they will be proportional. So if we go 68 divided by 20, second column divided by first column, we get 3.4. And then if we go 39.2 divided by 4, we get 9.8. Well, looking right there, 3.4 and 9.8 aren't the same, so this one is not proportional. Okay? Let's look at the next one. 2.54 divided by 10 is 2.54. 20.32 divided by 8 is 2.54. And 8.89 divided by 3.5 is 2.54. So is this one proportional? Yes, it is proportional. Okay, what is the difference here between this equation, the first equation we had, F equals 9/5 C plus 32, and this one is C equals 2.54n. The difference is right here. We're adding 32 to it. Here we're just multiplying on the bottom. Number 2, we're just multiplying right here. Okay? On number 1, we're adding 32. So adding this 32 throws it off, and it will not be proportional. So anytime you see an addition or a subtraction in an equation, it's an automatic not proportional. Okay? If you see multiplication, it is proportional, and some division is. Okay? So we'll talk more about that as we go on. On the next page, 65, total edge length, surface area, and volume. So here are some cubes with different side lengths. Complete each table, be prepared to explain your reasoning. So the edge length is where the two sides meet. So this is an edge, this is an edge, this is an edge, this is an edge. So I got 4 on the front, and I've got 4 on the back, and then I have 4 that connect the front and the back. So 4 plus 4 plus 4 is 12 edges on a cube. So all I'm going to do is I'm going to go 3 times 12. Or I'm going to take all of these numbers here and multiply them by 12. So 3 times 12 is 36. 5 times 12 is 60. 9.5 times 12 is 114. And 12 times s is just 12s. The heck, why'd that go away? 12s. Okay? What's the surface area of each cube? Okay, the surface area is the covering, like that. And there's a side over here, side over here. So on a cube, there are 6 sides. Okay, think of a dice. There's 6 sides on a dice, 6 sides on a cube. So we're just got to find the area of each side and then multiply by 6. So each side on the smaller square is 3 by 3. So the area of a square is just length times width. So 3 times 3 is 9, and 9 times 6 is 54. 5 times 5 is 25, and 25 times 6 is 150. 9.5 times 9.5 times 6 is 541.5. And then s, if my side lengths are s, so if I have this cube here, and I know the side lengths are s, I go s times s is not 2s, it's s squared. And then I have to multiply that by 6. So 6 sides times s squared. Okay? Moving on. What is the volume of each cube? Okay, volume is length times width times height. So on a cube, all the sides are the same. So we're going to go 3 times 3 times 3. And we get 27. 27. Then we're going to go 5 times 5 times 5 in our calculator, get 125. 9.5 times 9.5 times 9.5 gives me, whoa, that's a big number. 5,369.875. And then s times s times s is not 3s, but it's s to the third power, or s cubed. Okay? Which of these relationships is proportional? Explain how you know. Well, we can figure out if they're proportional if we go second column divided by first column. So on this first one, total edge length, 36 divided by 3 is 12. 60 divided by 5 is 12. 114 divided by 9.5 is 12. And 12s divided by s is 12. So this one is proportional. Okay? So it wants us to come up with an equation. So I know my constant proportionality is 12. So 12 times my side length, 12 times s, equals my total edge length. So we'll go t for total. So there's my equation. T equals 12s. Okay, now let's move on to surface area. 54 divided by 3 is 18. 150 divided by 5 is 30. Well, we were right there. We know 18 and 30 aren't the same, so that one's not proportional. So we can't write an equation if it's not proportional. Okay, let's look at this one. 27 divided by 3 is 9. 125 divided by 5 is 25. Not proportional. So we can't write an equation. Okay? So the thing here is if there's any exponents, anytime you have an equation with exponents, it's an automatic no. So the no's are anytime you have an equation with addition or subtraction or exponents and some division. And the yeses are multiplication and some division. Okay? So 8.4 wants us, 8.4 is on page 67. It wants us to go through and fill out the table. We're just going to look at the equations. So right here, 4 plus x, well there's that plus, so this is an automatic no. 4x means 4 times x, it's multiplication, so it's an automatic yes. Here we have division on the next one we have division. So here's the rule. When x is on the bottom of the fraction, or we're dividing by x, it's a no. When x is on the top of the fraction, the next one, the answer is yes. Okay, so we got to look to see where x is on that fraction. If it's on the bottom of the fraction, it's a no. If it's on the top of the fraction, it's a yes. Okay, the next one, 4 to the x power, well, there's their exponent, so that's a no. And x to the 4th power, still a no. Okay, so no, yes, no, yes, no, no. Okay, and that's it for the day. So the summary, if two quantities are in proportional relationship, then their quotient is always the same. This table represents different values of a and b, two quantities that are in a proportional relationship. Notice that the quotient of b and a is always 5. So what they did is they just went second column divided by first column, and they got 5 every time. So this would be proportional. So to write the equation, I would go 5 times my first column, 5 times a, and that equals the second column, b. So b equals 5 times a. That's what they have right down here. Okay? If the quantity y is proportional to the quantity x, we will always see the pattern y over x, or the constant proportionality will be the same. This value is the constant proportionality, which we often refer to as k. We can often represent this relationship with this equation, blah, 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 blah. So on your assignment today, you're going to be filling out charts, and then you just have to figure out, is it proportional or not? Once again, you can always watch the videos if you get it wrong, or you can email me with questions. Thanks.